Lesson 9.2, Solving Quadratic Equations by Factoring. This lesson is very similar to yesterday's lesson. All of these equations are equal to 0 again, just like yesterday's. However, we don't have groups multiplying like this one looks exactly like yesterday's. The rest of them don't. So basically today's lesson is how to essentially get this equation to look like this one, because this is really easy to solve. All right? So let's take a quick kind of reminder. You guys use your calculator to check your answers. I would say like 80% of the time your calculator can just straight up give you the answer, but we want to make sure that we know this process for the other 20% of the time where we have to find decimals or when it's just not quite as simple. All right, so let's take a quick look at the first one. This is what we did yesterday. So let's remember that x times x minus 9 is giving us 0. So that means that this x is 0, or that this group is equal to 0, right? And that's the only way that we could get 0 when we multiply. So either one or both of these are equal to 0. All right, well, this one's easy. All right, if x is 0, 0 times whatever is going to give me 0. All right, well, we could possibly also have, sorry, I'm having problems. There we go. We could possibly also have this group, x minus 9, be the one giving us 0. So what would x be for this whole thing to give us 0? Well, just solve for x right here. Looks like if we use 9, we'll get a 0. Right? So if x is 0, we get 0, or if x is 9, right? Because 9 minus 9 would give us 0. Either of those would work. Now in your calculator, I went ahead and typed that in there already. Take a look at your graph and notice that, yeah, we have a 0 right here at 0. And then over here at 9, we have a 0. So 0 and 9 are the two x values that will give us 0 for this equation. Now problem 2 is looking a little bit different. And the problem here is that these two groups, these two terms, are not multiplying each other. The zero product property only works when we're multiplying. So let's go ahead and let's use my calculator, see if it can help me out here. Let's graph this thing. Let's see, we got 25x squared plus 5x, and I want to know when it's equal to 0. Okay, well, let's just look. Where is it equal to 0? Ooh, that is quite ugly. Did I mess that up somehow? See, 25x squared plus 5x is equal to 0. Let's graph it. Yeah, wow, that is not a nice graph, is it? All right, so this is where it's going to be really helpful for us to know how to do this by hand. All right, we can see that it's 0 or very close to 0. Let's actually do the math here. And what we got to do, y'all, is we have to do your favorite thing. We have to factor. All right, we have to factor. So the very first thing we do when we factor is we check for a GCF. Do 5x squared and 5x have a GCF? Yeah, they do. Let's see. Both of them are divisible by 5, and they both have at least x. All right, we can't go bigger than that because this just has x. All right, so 5x is our GCF. So factoring means that we take out the common factor, and we do that by dividing. So we're dividing out the GCF. So now that's sitting on the outside of parentheses, which we kind of bring in here, and we find the leftovers. All right, well, 25 divided by 5 is 5, and x squared divided by x leaves us with just x. All right, and always double check. 5x times 5x would give us 25x squared, so that's correct. And the next one we have the x's canceling. 5 divided by 5 is positive 1. If you don't put the 1 there, you're going to mess this up. Okay, now I can do this exactly like I did the first problem. Now I can do it this way. So I'm going to have this set, this 5x equal to 0. Right, I could get 0 that way. And this group, 5x plus 1 equal to 0. Right, one or both of these is giving me a 0. So find x. We're going to divide out 5. So I've got x is equal to 0. Let's look at this graph again. Let's see here. Yeah, it does look like there's a 0 right here, isn't it? Right there. All right, so that one makes sense. Let's find it in the next part. We're going to solve for x. We're going to subtract 1 from both sides. Now I've got 5x equals negative 1. Divide by 5, and I've got x equals negative 1/5, which is negative 0.2, which is a pretty small number. And again, look at my graph. That makes sense because a negative 0.2 is Yeah, that makes sense. That's reasonable looking at this graph for it to be a negative 0.2. So 0 and negative 1/2, sorry, negative 1/5 are the two numbers that make this equation equal to 0. Let's try number 3. All right, I'm going to graph it here real quick. And we're going to go to y equals. We're going to type this new one in there. It looks like I've got x squared plus 13x plus 40. And don't forget that we really are looking at the graph here, so let's go. Ooh, this one looks nice. Looks like my answers are going to be negative 1, 2, 3, 4, 5. Negative 5 and 6 and negative 8. So negative 5 and negative 8. Now we probably could just stop here, honestly, and say those are our answers. But let's remember how we factor something like this. Remember that we look at, first, is there a greatest common factor? No, not all the terms have x. And we don't use 1, right, unless we absolutely have to. So we don't really have any GCFs here. So what we're going to do is we look at a times c and we look at b. All right, we look at a times c and we look at b. A times c, in this case, 1 times 40. That's going to give us 40. And b is the middle term, which is 13. So we need two numbers that multiply to 40, but that add up to 13. Well, a good way to start is to make a quick list. What multiplies to 40? I know 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 works, 5 times 8, 6 doesn't work, 7 doesn't work, 8 works, but I already have it, so that's my list. All right, so I would choose 5 and 8 because that's the only set that adds up to 13. Okay, now I'm going to do this factoring a little bit differently than previous videos. Instead of using grouping, I'm going to go ahead and use the box method, especially because there was not a GCF. All right, so I'm going to draw a box here. And I'm going to go ahead and I'm going to put, you know what, that box is too big. Let me draw a smaller one here. Sorry. Here's my box. Okay, this term goes right here. So I've got x squared. Then we've got the 40 at the end. We know the constant goes right here. And now what goes in these boxes? Because I only have one term, right? I can't put 13 in both places. This is where you use the 5x and the 8x, right? This is where you use these terms. So once you have your numbers in the box, you're looking at your GCFs, your greatest common factors. So we do this doing it in columns and in rows. So what is the greatest common factor of x squared and 8x? All they have in common is just x, or 1x. What is the greatest common factor for 5x and 40? Well, they don't both have x, so we can't use that. But they are both divisible by 5, so we get to put a 5 right here. So we got the top, now let's look at the side. X squared and 5x, what do they have in common? Well, they both have x, and that's pretty much it. And then finally, 8x and 40, they do not both have x, but they are both divisible by 8, so I get to use 8. So these groups are my two factored parenthesis sets here. I'm going to have an x and a positive 8, and an x and a positive 5, and that's equal to 0. So I took this and I rewrote it in factored form, right? And I did this so then I could solve this pretty easily. I can say x plus 8 is equal to 0, or the other group, x plus 5 is equal to 0, and then solve this thing really quickly so it looks like negative 8 or negative 5 are the two numbers that make this equation 0, right? And we totally saw that from the graph, but this is how you would do it the long way by hand, right? And if nothing else, this is just a great factoring review. Okay, let's take a look at number 4. Again, I'm going to start with my calculator this time, and from now on, if my calculator gives me the answers easily, I'm just going to take them. Okay, so let's look. We have got to type in 2x squared minus 5x minus 3, and let's take a look at my graph. All right. This one looks like negative 1/2, but I can't be sure. I can't just guess. And this one is definitely 3. So I've got one answer given to me and one of them that I'm not quite sure about. So I'm going to go ahead and I'm going to do this problem like I did problem 3. I'm going to do the factoring. please, y'all, take the time to write this down with me because it's such great review for factoring, which is something that we struggled with. Okay. GCF? Nope, no GCF, so I can go ahead and get started. Let's look at A times C, and let's look at B. A times C is going to be 2 times -3, which is -6, right? The product of these two numbers. B is the number in the middle, so -5. So what multiplies to -6 but adds up to -5? Well, make a quick list. I got 1 and 6, 2 and 3, and that's my whole list. Since I want it to add up and be a negative, my bigger numbers are the -1s. So which of these will add up to -5? This one. So 1 and -6 are the two numbers that I need. Okay, so let's do my box method here. We know the 2x squared goes in this spot, and the -3 goes in this spot. But I don't want to use -5x, right? I can't put it in both places, so I'm going to use my +1x and my -6x in the box. And now we're looking for greatest common factors. So in this column, they're both divisible by 2, and they both have x. So I'm going to use 2x. In this column, they got nothing in common, literally nothing. They don't both have x, and looks like 1 is the only GCF, so all we can do is just put a 1. In this row, the GCF is going to be 1, which we would write, oh wait, they both have x, so I'm going to write x instead of 1. Or you could write 1x. And then finally, 6 and 3, -6 and -3, right? They're both divisible by 3. And since I'm touching this box right here that's negative, I have to make my sign negative. So I got my two groups, right? I have my x and my -3, right? That's this one. And my other group is going to be a 2x and a +1 that's coming from here. And it's equal to 0. So again, this just got rewritten to its factored form. And this allows me to solve it using my zero product property pretty quickly. Looks like I've got x minus 3 equals 0. And then this group, 2x plus 1 equals 0. And now I'm just solving these. So we kind of already knew that one of the x's was 3, right? We knew that from the graph. One of the x's that made it 0 was 3. And this other one we expect to be -1/2, but we're checking to be sure. Let's see. I'm going to subtract 1 from each side. Divide by 2. Looks like I've got x equals -1/2. All right. I guess my guess was correct. So 3 and -1/2 make this equation 0. Last example, x squared minus 36. All right, let's use the calculator again. And y'all, if it gives me two easy, clear answers, we're going to call it a day. All right, x squared minus 36. Look at the graph. Yay! All right, I got -6 here, and I got +6 here. This is nice. This is great. I'm not going to do the whole show for you. I'm going to just say, checked my graph. Checked my graph. I got x equals 6. I got x equals -6. Okay? So if you can just check your graph, just go ahead and do it. But sometimes you got to do the work if you get a decimal, right? Because you don't want to guess on decimals. All right? Other times, like these two, it's pretty clear and easy. Just go ahead and take the calculator's answer. Right? Just really understand that when you have these equations set equal to 0, you're literally looking on the graph for where they equal 0.